Okay, class, section 4.2, solving systems of equations algebraically using a method called substitution. But before we start doing that, I'm going to give you a couple of examples of why we don't always love graphing, why it's not my preferred method. So here's my first example. We're going to solve this system, and we're going to do it like we did in the last section. We're going to solve these for y and graph. So I'm going to get y equals positive x plus 1 by adding x to both sides. That's a pretty easy one to graph. I'll come back and graph that one in a second. Another one, divide everything by 4. I'm going to rearrange this side so that the slope part comes first. So I'm going to have y equals negative 3/4 x. And for my y-intercept, we're going to get 2. Okay, that's not too bad to graph either. We're going to have a y-intercept of 2, and we will rise 3 and run 4. That's all the points I can get in this direction, so I'll go back here, down 3, 4 in that direction, and those are the only 3 points I'm going to get from that equation. Now for the one on the bottom, y-intercept at 1, that point there was an accident. Y-intercept at 1, and it has a slope that is positive. So in the last section, I just made dots, and I didn't connect them because I was just looking for where they intersected. Now here, these two lines pass, and it's going to look a little something like this. And you can see our solution is going to be right about there. And I would guess from looking at it that it's maybe 1/2 to the right and 1.5 up, but it doesn't quite look like a half, and I'm going to show you that it really isn't. So I'm going to show you a substitution before I even show you how to do it. Here we've got two equations. They're already solved for y. Now they both equal y, so they equal each other. So I'm going to set the x plus 1 equal to the negative 3/4 x plus 2. And I'm going to solve this for x. I'm going to add 3/4 x to both sides. So when I do that, I'm going to want to add it to this. I'm going to make that 1x into a 4/4 x so that I can add 3/4 x to it. Then I've got the plus 1 on that side. And this plus 2, it stays there, but the negative 3/4, it's gone because it was added to both sides and it cancels out on that side. So I have 4/4 x plus 3/4 x is 7/4, 7/4 x. And then I'm going to go ahead and subtract 1 from both sides, and I get 7/4 x equals 1. I'm going to multiply both sides by 4/7. Multiply by the reciprocal to cancel out a fraction in one step. So this becomes 28/28 x, or 1x, or x, equals 4/7. Now 4/7 is pretty close to 1/2, but you know what? I never would have guessed 4/7. It never would have crossed my mind. So the graph didn't really give me a good idea of the answer. It's an approximation, but not the actual answer. Now I could actually finish this and get my answer because this is a pretty easy equation to plug into. So I'm going to take that negative, or positive, sorry, I'm going to take that positive 4/7 x and plug it in, and I get y equals 4/7 plus 1. I'm going to change that 1 to 7/7. So I can add it to the 4/7. So I'm going to get 11/7. Now that is 1 and 4/7, and that looks about right. So my answer was 4/7, comma 11/7, and I did not get that by graphing, and I never would have thought to. I got one more example for why graphs maybe don't work. So I've got this first equation up here, and it doesn't seem like something you'd want to graph because it's got a y-intercept of 4/5. Now we'll show you a way to actually get a good answer out of this. So I blew this graph up so that I can get a little bit of accuracy. I'm going to go out 1, 2, 3, 4, 5, and put a 1. I'm going to go up 1, 2, 3, 4, 5, and put another 1. So every one of these blocks is 1/5. 1/5, 2/5, 3/5, 4/5, and then that's 5/5, or 1. I'm going to do that in every direction, but I'm not just going to write that because it's going to get a little bit congested with some messy handwriting. So just going to leave this down here as a reminder that each one of my blocks is 1/5, so my scale is 1/5 in each direction. So now when I go to plot this, 4/5 for my y-intercept is right there. Now the 1/2, I can go up 1 and over 2. Up 1 and over 2. And when I show this method to students, they often question this part, like, why don't I go up 1, which would be like way up there? It'd be like up 5 blocks. And then over 2, it should be over 10 blocks. Well, if I did that, think about going up 5 blocks and over 10 blocks. 5 blocks over 10. Well, that's just the same as 1/2. You see, it's a fraction, and it simplifies. So I can just go up 1 block and over 2. So these fractions for the slope, they never change. You can always just use them just how you see them. All right, this one right here, y-intercept of 0, because it's plus 0. So it's right there. And it has a slope of -1/2, so I'm going to go up 1 over 2, up 1 over 2. And I actually have an answer here. It's over 4 blocks, and it's up 2 blocks. Now remember, each of my blocks was worth a fifth. So it's -4/5, comma, 2/5. Now, this one I could have solved graphically because I had the wisdom to look at that y-intercept and go, I'm going to make each block worth a fifth. And then by chance, I had an answer that fell on a grid location. But on the last one, I didn't know that that was going to not have an answer that I was going to be able to find. So I almost never use graphing as a way of solving systems. Alright, substitution has a couple of steps you want to write down. Step 1, solve one of the equations for one of the variables. Now, it could be both, but it doesn't have to be both. So that is already done here, because in the top equation, y is solved because it is isolated. Step 2, plug that result into the other. That's important that it's the other equation. And solve for the other variable. So this is y. The 2x minus 9 is y. So that's going to go in right there where there is a y. Alright, now we're going to have to do some work. So I'm going to have negative 3x equals negative 15 minus, you know what? I'm not going to do this. I see a negative for every single one of these terms. I'm going to multiply this by a -1. Scratch, scratch, scratch. And I am going to get 3x equals positive 15 plus y. Way easier. I'm going to plug this in there. So I'm going to get 3x equals 15 plus, and then my y. 2x minus 9. Now solve this for x. Combine like terms on this side, so I've got a 15 plus a -9 is like 15 minus 9, so that's 6. So 3x equals 6 plus 2x. Subtract 2x from both sides, and we get x equals 6. Now I'm going to put a little balloon around that. It's not my answer because my answer needs an x and a y. So I'm now going to do step 3. Plug your result from step 2 into any equation. So I'm going to plug it in the simplest spot, which is probably going to be here, because that's already solved for y. So I'm going to get y equals 2 times 6 minus 9. That's 12 minus 9. That's 3. So I now have the other part of my answer. Now, there is a step 4, and I rarely get students that will go through this and actually finish step 4, because step 4 is checking your answer, but that is something that you should do. So plug 6 and 3 back in, and, well, it should check out for my top equation because I just got my y using that top equation. So at the very least, plug it into the other one. And, this negative, this equation that has all negatives, that's equivalent to this one. So I'm actually going to check this equation with my answer and see if it's okay. And that's going to satisfy my step 4. So step 4 is check. So 3 times 6 is 18. Is that equal to 15 plus 3? And the answer is yes. So I've got my answer. It's 6, 3.